All right, grade 7, we are looking now at our sampling methods. Remember, probably the first step in statistics, the second step, the first step is asking, what do I want to understand about the population? The second step is, how am I going to gather that information? How can I take a sample? Remember Mr. S's pumpkin soup. How can I stir the pot and take a good, not big, but a good spoonful of mixed soup so that I know exactly what that soup really tastes like? And so we noticed that the most foolproof, we call it the SRS. That's just that simple random sampling. It's the best. But sometimes, for practical reasons, there's going to be some other sampling methods that, while they're not as foolproof as the SRS, sometimes they're easier to do. And sometimes they can actually make some other observations more interesting. So one of the ones that is actually one of the more popular methods, which is fun because it's going to be great for comparison, is this next one. Okay, so remember, SRS is kind of like the top. That's the ultimate. After that, though, I would say that the stratified sampling method can be extremely helpful. What a stratified sampling method does is it's taking, as you remember, learned in earth science in grade 6, the strata are going to be the layers. And so what you're trying to do is you're trying to take your population, you're trying to examine layers, and you're going to take a simple random sample from each of those layers. Okay, so in other words, you're dividing the population into groups, and in those groups there's going to be something in common about those groups. Like, it could be gender based, it could be girls and boys, or it could be age based, from 15 to 20, from 20 to 30. You could be dividing your population by age, or you could be looking at, if you're doing a study on fruit, you could do the citrus fruits as compared to like the different varieties of apples, or something something like that. So what you want to do, for example, in a school, you could do, if it was a school example, you could say, okay, I'm going to divide this by grade level. So this could be, grade 6, grade 7, grade 8, grade 9. Or maybe you want to do it by section. This is going to be the elementary school. This is going to be the middle school. This is going to be the high school. I'm dividing the school into different subgroups, and then I'm going to take an SRS for each of those subgroups. I'm going to take the sixth graders. I'm going to give them all a number. I'm going to randomly choose 5 numbers. The advantage of this stratified is, not only do I get a pretty good glimpse of everything, I'm able to make sure everybody is represented, but I'm also able to compare. That might bring up something interesting. Maybe I can later, besides understanding the school, I can say, oh, the school says this, but specifically, high school and middle school like this, while elementary school like something else. So stratified sometimes is even more powerful than the SRS because it's going to give you the ability to make some comparisons. Okay, that's going to be important statistics, comparisons. Gender as well. Okay, obviously you can do male and female. All right, if you're doing a book, you might have chapter 1, chapter 2, chapter 3. You might be doing some chapters as well. So these are all going to be ways that are going to be helpful to understand your data. The question again, why? It helps us understand different subgroups for comparison. That's what a stratified random sample is going to do. A cluster sample now. The second one, the book doesn't talk about this, but I thought I would already go ahead and talk to you about this. A cluster is kind of like the opposite of a stratified group. The cluster is going to have some limitations, but sometimes it's going to be simpler. A cluster says this: let's choose a smaller group to represent the entire population. So instead, while the stratified said for the book, let's do each of the chapters, 5 words from each of the chapters. This is, let's just choose randomly chapter 3. Let's find out what chapter 3 says, and we can use that information to say, okay, that's what the book. So if I wanted to count, for example, how many verbs, I don't know why you would want to do that, but who knows, English people, how many verbs are there in the book? Well, I could use chapter 3, find the percentage of verbs in chapter 3, and assume that the author is going to be pretty consistent throughout the whole book. That wouldn't be a bad method. In a school, I could say, I'm going to randomly choose of the class. I'm going to choose grade 7 to represent everything. Now that's a little bit dangerous because most likely, depending upon the question, grade 7's perspective is going to be a little bit different than grade 6 and grade 9, certainly than grade 1 or grade 13. So in a school setting, that would not be a great method. Maybe just do a section, just middle school. Again, that might be good in the middle there, but again, middle school perspective is probably not going to be the same as high school. Why do we do this method? Well, one of the main reasons why it's usually cheaper and quicker to do. That's going to be one of the big advantages. All right, systematic now random sampling, which the book does talk about this one. This one's going to be pretty straightforward. It's very similar to the simple random sample, but systematic says this: I'm going to randomly choose one member. Let's just call it member N, okay? And after I get to N, I'm going to do every 100th person or whatever. So let's just say I have, in a school setting again, let's just say I have a list of all teachers. And I'm going to start with the one teacher. I randomly choose one teacher. And then in alphabetical order, every fifth teacher, I'm going to ask the question. Now, that would probably be fine. I would be a hard time thinking that the last name of an alphabetical list is going to have any kind of influence on what the teacher is going to say. Just because my last name begins with an S, I doubt that's going to change. My opinion is going to be vastly different if my last name started with an N or something like that. So it's not a bad method. In a book, it would be perfect. You could start with the 10th page, and then you could do, or whatever random page. Let's just say you randomly choose the 10th page, and then you could do every 7 pages or whatever you want. You're going to do your analysis on that book to count the number of verbs. That would be a systematic. You're randomly choosing the first one, and then you're saying, after that first one, every 100th, every 7th, every 10th, whatever parameters you want to use. So let's look at these and say, which method do we want to use? Remember, cluster's not part of our book one, so you probably don't have to worry about that one. But simple random sample, we're going to have a stratified, remember, looking at the layers, or you're going to have a systematic. Okay, those are going to be the options that we have here. Let's look and see if we can identify it. Scenario 1, a journalist would like to find out what attendees think of a large computer fair they are attending. He decides to interview 50 people. All right, so in this one, a simple random sample means every single person who comes would need to have a number, and he's going to randomly choose though. Well, if you're at a computer fair, it might be difficult to track down everybody. So an SRS would be very difficult in a situation like this. Stratified. How could I divide all of those attendees into groups? I'm not sure how I would do that, but systematic might be an option, because what I could do is I could start with a person. Let's just call it the 5th person, whatever I want. And then I could say, of all the people walking into this computer fair, I'm going to ask every 50th person, depending upon how many people are coming, every 50th. And when I get to 50 people, I'll stop. So let's just pretend there's going to be a lot of people coming to this, obviously, but usually there's thousands and thousands that come to a fair like this. So if I start with let's just say some person, and then I count all the people enter in, 49 people, the 50th, hey, I want to interview you. And then another 50 come in, hey, can I interview you? And you would choose that with a systematic approach. Let's look at another scenario. A poultry farm keeps 3,000 birds. An agricultural safety and health officer needs to check whether any of the birds might be infected with the virus and would like to take a random sample of 20 birds for inspection. This would be a pretty simple random sample, because I have these birds. I'm a farmer, so I could easily probably number them about where they're kept. I probably already have some kind of tracking system. I could just use a random calculator or a random website and enter in the numbers between 0 and 3,000, pick 20 random numbers. look at those numbers and see if they're infected with this virus. So a simple random sample would probably be the best. I probably already have some kind of list for my birds if I'm a farmer, so that wouldn't be too difficult. 3, a local authority plans to conduct an opinion poll of people in McCree County as to whether they are in favor of putting more restaurants in a historical landmark site. The county consists of 6 districts. The authority intends to generate a random sample of 300 to 400 people. All right. So in this one, now, I see that there's already some districts. It consists of 6 districts. So it might be interesting to say, in this area, what does each district think about putting more restaurants by this historical landmark? Because maybe the districts closer are going to be against it. Those farther away might be for it. I don't know. Maybe the opposite. How do we know? So finding out what those different districts, these are going to be obvious strata, right? And so we can see this is going to be a stratified. He wants to get a sample of 300 to 400 people. If I have 6 districts, I could just randomly choose 60 from each district. That would give me 360. That would give me 360, which would be between 300 and 400 people. I give everybody in the district a number. I randomly choose 60 from each. Now I'd be able to compare the districts to see if anybody has a differing opinion. All right. That's going to be the last part of our how we can sample. This is, again, how we stir the pumpkin soup. Doing these 3 or 4, if you include the cluster, these 4 methods, this is you stirring the pot. The better you do with this, the more random it is, the better that soup is stirred. And so when you take a spoonful, even if it could be 300 to 400, but it could just be like this one, 20 birds or 50 people. It doesn't have to be a large amount. But if it's stirred right, you taste the soup, you're going to say that's what the population actually looks like, or in my example, tastes like. All right, let me know if you have any questions.